All right, let's take a look at our first topic in Unit 1, heat, heat versus temperature. By the time you're done this section of videos, you should be able to explain the difference between heat and temperature because they both mean different things. All right, so we're going to take a little background information here on the kinetic molecular theory. Now, we need to define these two terms in scientific thinking. What is a law and what is a theory? And a scientific law, we're going to start with law, is simply a statement based on repeated experiments or observation that describes a natural phenomenon. For instance, we have the law of universal gravitation, which is simply a statement, in this case it's a math statement, that describes how two things are attracted gravitationally. We have the laws of thermodynamics, which are three laws that describe how energy works in the universe. A theory is an explanation of a part of the natural world that can be tested or verified using the scientific method. So a theory is an explanation of a part of the natural world that can be repeatedly tested with the scientific method. So, you might have a theory on, let's say, there's a standard theory of evolution. The theory of evolution is an explanation of why things are the way they are in the natural world. And you can test to see whether evolution happens or not. It's difficult, but you can. You can test to see if organisms mutate and they have changes that allow them to adapt to their environment, things like that. So then after that theory has some scientific data that supports it, then it can become a law, a statement that's based on that repeated experiment or observation. So you kind of start with a theory, you do some experiments, and those experiments show something to be true, and then that turns into a law, a statement that has been based on the experiments. Okay, so you start with the scientific theory, do the experiments to see whether your theory is true or not, and then if your experiments work out enough, you get a law. Now we're going to look at the kinetic molecular theory of heat. It's important to know, kinetic means movement. And molecular means molecules. So the kinetic molecular theory states that all matter is made up of molecules. And sorry, I'm wrong already. All matter is made up of atoms, which may combine to form molecules. And of course, atoms are made of protons, neutrons, and electrons. And protons, neutrons, and electrons are made of quarks. Atoms and molecules are in a constant state of motion. And by being in a constant state of motion, they have energy. Okay, so by being in a constant state of motion, they have energy, kinetic energy. Kinetic energy is energy of movement. All right, now, atoms and molecules exert an electrostatic force. Force on each other. These forces are attractive when the atoms and molecules are closer together. However, if the atoms and molecules are too close together, the force becomes repulsive. So if you've got, let's say, I'm going to just draw a picture over here. You've got one atom over here, one atom over here. These two guys are going to attract according to the electrostatic force. But then they come together and they get too close, then they're going to repel. It's kind of a weird thing, but that's the way it is. Now, we're going to fill in a few blanks here. So, this thing maintains their shape and volume, and the electrical forces cause, well, solids. Well, this is not a good statement, but the word out here is solids. Solids maintain their shape and volume. You look at a solid object like a piece of wood, it maintains its shape and volume. It doesn't change its shape and volume. The electrical forces cause the solids to vibrate about a fixed rigid position. Okay, so when molecules are in solid form, the energy they have from motion isn't because the atom is moving around and like this. It's because the atom is staying in one spot and it's vibrating back and forth. It's just vibrating. In a solid, the atoms are connected to other atoms with chemical bonds. And so they can just vibrate. Now, solids maintain their shape and volume. Then liquids take the shape of their container, but have a fixed volume. Liquids are incompressible. You have 500 milliliters of water, you can't compress it. It will always be 500 milliliters. Atoms and molecules move about quicker than in solids, so the attractive force between the molecules is weaker. There is an attractive force between the molecules, but they can kind of slip around from one molecule to another. So, in a gas, atoms and molecules move about very quickly. High kinetic molecular energy. A lot of energy in a gas. And the attractive force is very weak, almost non-existent. Molecules can just move past one another. Atoms and molecules are further apart than in liquids and tend to move out in all directions. Gases do not maintain their shape nor their volume. So a gas will spread out. Molecules have potential energy holding them together. That potential energy is chemical in nature. We can release that potential energy by doing a chemical reaction. We're not worried about that in this part of the unit. What we're worried about is the kinetic energy of the molecules, the energy of the motion. They also have kinetic energy because of their motion. That's what we're worried about. So let's draw a little picture of solids, liquids, and gases. So we've got some solids here. Now solids have the molecules all joined together. So I'm just going to draw a solid. And all of them are joined together with chemical bonds. So these here are molecules. And the molecules vibrate. They vibrate back and forth. They're stuck in their spot, but they vibrate. And this vibration is a motion which has energy, kinetic energy. All right, now liquids. Liquids are in a container. And the liquids, the molecules kind of aren't really joined tightly together. And they will form the shape of... Now, in the liquids, the molecules, they vibrate. So this molecule at the top, he vibrates. They vibrate. That's part of their energy. But the molecules also have the ability to move around. So they can also move. Now, if you take this water that's in this cup and you pour it into a different container, it will change shapes. The molecules move around each other. There's no rigid connection like in a solid. Now, in a gas, the molecules are spaced apart. The molecules vibrate, but they also move really fast. So in a gas, generally has the highest amount of kinetic energy in it. So the solids have the lowest kinetic energy. While the gases have the highest kinetic energy. Now, this is in general for a single substance. So like solid water has lower kinetic energy than liquid water, and liquid water has lower kinetic energy than gaseous water. Okay, so the kinetic molecular theory of heat states that heat, what we call heat, is caused by the motion of the molecules in the material. There's two types of motion. There's vibration, where the molecule stays in a single spot and vibrates back and forth, which happens in solids. It also happens, molecules can vibrate in liquids and gases too, but they also move around freely in liquids and gases. All right, so we're done with this section of kinetic molecular theory, and in the next video, we'll take a look at the next section.